Let's have a look at this exam question. This is November 2019. So we're dealing with first order linear differential equations. How do you know it's first order? You can see dy over dx first derivative. Okay. So this one is 6 marks. Determine the particular solution. So we will not stop at the general solution. Once we work out our general solution, we will then substitute for x and y and find the value of c. Right, so let's start with that. So this is clearly not in standard form. We keep our two terms on the left. So what we can do here is we got x times dy over dx minus 2y is equal to 3x cubed minus 5x squared. Now, all I have to do is divide by x because I want the coefficient to be a positive 1. So I'm going to divide by x or multiply by 1 over x. It means the same thing. So here I got my positive 1 dy over dx minus 2 over x times y. Here this will be 3x squared minus 5x. Right, so now this is in standard form. So my standard form is dy over dx plus py is equal to q. You must always have the standard form in mind. Now, the next step is get your integrating factor. So your integrating factor is given by the formula e to the integral of p dx. So let's write down our p and q. So what is p? P there is minus 2 over x because it is plus p times y, and q is the right hand side. So my q there is 3x squared minus 5x. So that's my p and q. Let's do the substitution. Right, so now we can integrate. We've done one like this previously. So we integrate, that will be minus 2 ln absolute value of x. So therefore my integrating factor is equal to e ln x to the power minus 2, which is the same as, you all know the log law, we've done it. So this will be just x to the power minus 2, which is the same as 1 over x squared. Now we substitute into the formula. Y times your integrating factor is equal to the integral of q times your integrating factor dx. So that's y times 1 over x squared. Your q is 3x squared minus 5x times the integrating factor there, which is 1 over x squared. So we got y over x squared. We need to simplify first. So 1 over x squared times term 1 will be 3. 1 over x squared times term 2 will be 5 over x dx. And now we can integrate. So when we integrate the right hand side with respect to x, this will be 3x minus 5 ln absolute value of x plus c. So this is, at the moment, this is called the general solution. Now, we will not stop there in this exam question. You asked to find the particular solution when at this point 2, 1. Okay, at a specific point. So at, we got when x is equal to 2, y is equal to 1. Let's do the substitution. So that will be 1 over x squared, so that will be 2 squared is equal to 3 times x, which is 2 minus 5 ln absolute value of 2 plus c. We will now find the value of c. So that's going to be 1 over 4. Work it out on the calculator there first. So that will be 1 over 4 minus 6 plus 5 ln of 2 is equal to c. Give me the answer there, rounded up to 3 decimal places. One over 4 minus 6 plus 5 ln 2 is equal to minus 2 comma 284. So we found the value of c. So therefore, our particular solution is particular, or you can call it a unique solution. So what do? You go back to the general solution, substitute the value of c, and that will be your particular solution, your final answer. So we got y over x squared is equal to 3x minus 5 ln absolute value of x minus 2 comma 284, and that was your 6 marks, November 2019. Our next question we're taking from March 2018. So here they asked you to determine the general solution of this. It's a first order again. So here, let's see what we need to do. We need to divide by x again. So if dividing by x on both sides, it's the same as multiplying by 1 over x. So let's see what happens. So what happens here, it will be a 1 times dy over dx plus 2 over x times y. And x will cancel here, so you end up with just e to the power x. Right. So now we get our p and q. So our p is 2 over x, q is e to the power x. So now our integrating factor is e to the power the integral of p dx. Substitutes. So now integrate 2 over x, that will be 2 ln absolute value of x there. So that will be e ln x all squared, which is equal to x squared. Right. So now that is our integrating factor. So the formula is y times your integrating factor is equal to the integral of q times integrating factor dx. So it's going to be y times my integrating factor is x squared is equal to the integral of q. What is my q? Q is e to the power x times your integrating factor here, which is x squared. Now, okay, this everything was easy up to this stage here. Okay, nothing difficult at the moment, because the previous example had a negative, this one has a positive. But now it will take long, depends on what method you are using. This is integration by parts. Whether you're in N5 or N6, integration by parts, you must know, you can see. It's a common thing. Now, with integration by parts, remember the formula is the integral of f of x times g prime x dx is equal to f of x times g of x minus the integral of g of x times f prime x dx. That is the formula. So, multiplication is what we're dealing with. You multiply e to the power x times x squared. Now, obviously, we use integration by parts because at this stage you can see that there's no exact derivative here. Check the exponent. The exponent is x, and the derivative of x is 1. It will not cancel there. So, now we go to our priority list. You should know your priority list. Number 1 is inverse, number 2 is logs, number 3 is your powers of x, and there's number 3 here, and this is number 4. So number 3 is what you need to choose as f of x. So my f of x is going to be x squared, so therefore g prime x is going to equal to e to the power x. Now I'm going to use this method, which I'm calling the table method. Right, so there's nothing wrong with using this method, but you need to state that you are using this method, and you must show your steps. It works much faster than keep on writing the formula over and over again. Because here, because of the power 2, you're supposed to use the formula 2 times. If this was a power 3, you will use the formula 3 times. But there's an easy way to do this. All you do is you identify f of x, differentiate it. The derivative of x squared is 2x, the derivative of 2x is 2, the derivative of 2 is 0. You differentiate down to 0, and in line you integrate everything. So you integrate e to the power 1x is just e to the power x. Integrate it again, e to the power x. Integrate it again, e to the power x. You're clear with that? So now we're basically substituting into the formula all at once. So it starts off with this is a positive and that's a negative. So we start with a positive and then a negative, and then the second time positive and then negative again. Okay. So it's positive, negative, positive. If we carry on negative, positive, it just alternates. Right, so what do? You multiply f of x times g of x. This is not g of x, this is g prime. So there's g, so that's why you multiply going down. So there. Now watch how this is done. So therefore, let's write this down properly. We got y on my left hand side, x squared. I'm copying down the differential equation is equal to now what you're going to do is multiply. So it's going to be x squared times a positive times a positive times a positive is positive here. Then a negative times a positive times a negative will be negative 2x e to the power x, and then a positive, 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 there will be plus 2 e to the power x plus c. That is a table method. Very fast it can be done. You can see that this is the general solution. Now the table method works because we can differentiate this. This is the only one we can differentiate down to 0. So don't go and try it with all the examples. Right, so let's have a look at November 2017 paper. 6 marks, find the particular solution. So we will go as usual, find the general solution. So how do we do that? Make sure our equation is in standard form. So here we got the negative, we can leave it there as it is, or if you want to, you can put a plus What you can do is you can write it down like this, although it's unnecessary, but you can write down a positive, and then you have your y. Remember, p needs to be multiplied by y, so p is actually minus 1 over x. And you can see that is equal to x plus ln x. Now we identify our p and q. So p here is minus 1 over x, and q is x plus ln x. So now we need to find the integrating factor. The integrating factor is given by the formula e to the exponent, the integral of p dx. So let's do the substitution. P is minus 1 over x. So now you can see it's a common thing, this minus 1 over x. Integrate minus 1 over x, so that's minus ln absolute value of x. So now you cannot simplify straight because of the negative. So that will be e ln, use your log law, make negative 1 become an exponent, and only now you can simplify. So it's equal to just x to the power minus 1, which is 1 over x. Right, so now that is my integrating factor. The next step is to go straight to the formula. The formula is y times your integrating factor is equal to the integral of q times your integrating factor. Now let's do the substitution. So y times my integrating factor is 1 over x is equal to, so my q here is x plus ln x, and it's multiplied by your integrating factor there, which is 1 over x. So what do? We simplify as far as possible, and then we can integrate. So my right hand side, I need to multiply 1 over x by term 1, 1 over x by term 2. So x times 1 over x is 1. Ln x times 1 over x is just ln x over x. Alright, so now that's as far as we can go with simplification. So now we are dealing with the n5 work now, which is integration only. So we will integrate 1, and then we need to integrate ln x over x. Now, ln x divided by x, let me just show you what's going to happen here. In that case, we have the integral of f of x to the power n times f prime x dx, where n must not equal to negative 1. So if this is the situation, then the answer is always by inspection. It's f of x to the power n plus 1 all over n plus 1 plus c. So how is that possible here? So now we have the integral of ln x over x dx. Alright, so now can we see f of x, f prime x? So you must know your differentiation mentally. So you can just look at it and see that the derivative of ln x is 1 over x. So what am I saying? So that I have ln x divided by x is the same as multiplied by 1 over x. Can you see that? Okay. So what is the power here? It's 1. So now my f of x is my ln x. My n is 1. F prime x is the exact derivative of ln x, which is 1 over x. it satisfies this condition 100%. So all you do is you go f of x, which is ln x, n plus 1, that's 2 over 2, plus c. That is our n5 type A multiplication exact derivatives. Okay, so let's do it here. Right, so now we're going to integrate 1, which is x. Integrate this here, that will be plus ln x squared over 2 plus c. So now that is our y. Okay, y times 1 is y over x. That is my general solution. Okay, so now I'm going to work out the particular solution. Alright, so what happened now? We have, this is just the general, so I'm writing GS, let me just write it down properly. This is the general solution. Now, for this exam question, for 6 marks, they asked you now, find the particular solution when x is equal to 2, y is equal to 1. So what do? All we do is substitute for x and y into the general solution and find the value of c. So what do we have at this point where x is equal to 2, y is equal to 1? So I'm going to substitute y over x. So that's going to be 1 over 2, because y is 1, x is 2, is equal to x. So there's my x here, which is 2 plus, so that's plus ln x, so that's ln 2, all squared, all divided by 2, plus c. Take out your calculator and work this out here. Let's work out the value of c. So that's 1 over 2 minus 2 minus 1 over 2 times ln 2 squared is equal to c. Okay, give me the answer fast then on the calculator. Do this. Round it up to 3 decimal places if possible. What do we get? Come, time is running out here. Simple thing. Type it out, give me the answer. I'm not asking you to go and write an exam, just take out your calculator and press the right buttons and give me the answer. That's it? Negative 1,740. Does everyone get the same answer? Right, so that is C. So therefore, now we will write down our particular solution. So all you have to do is take C, substitute it back into your general solution, and that is called the particular, or it also can be called unique solution. So what we're going to do is we go back here. So we're going to have y over x is equal to x plus ln x all squared over 2, and then substitute for c. There's your c there, which is minus 1,74. If it's a 0, you don't have to write it down. So that is your 6 marks from November 2017. Let's deal with the next one. Our next question here, we're dealing with March 2015. This one is 5 marks. Solve the differential equation. So now this one is, we need to rearrange this, we need to manipulate this. So here, we notice that There's no dy over dx. There's dy this side, dx on that side. What we need is dy over dx. So remember, always keep in mind your standard form, which is dy over dx plus p times y is equal to q. So there's dy here. If I want dy over dx, what will I do? I can multiply by 1 over dx, so I'll have my dy over dx now. Can you see that? So whatever I do on the right hand side, I must do on the left hand side. 1 over dx. Remember, you're dividing by dx, so dx must not equal to 0, obviously. But let's see what happens. So 1 over dx times this here, you'll end up with x squared sine 1 over dx times term 2 will be minus y is equal to x times dy over dx. Okay, now I have my dy over dx. I need my term with y next to it. Can you see that? So if I take this to the right, so that's going to be x squared sine x is equal to x dy over dx plus y. Okay, so I'm almost there. Only problem now is the coefficient supposed to be 1, it is not 1. So what must I do? I don't want this x here, so I will multiply by 1 over x. Whatever I do on the right hand side, you do on the left hand side. So now, x times 1 over x is just 1 times dy over dx plus y times 1 over x, that's 1 over x times y. And here x squared and x will cancel, so you end up with just x sine x. Right, let me just transfer it to the left hand side, since we are used to writing it on the left hand side. So dy over dx plus 1 over x times y is equal to x sine x. I am not transposing, that means I'm not going and taking this to the left hand side, I'm copying. What I'm doing is I'm copying what's on the right, on the left, and I'm copying what's on the left, on the right. Okay, so I'm not changing any signs here. So why am I doing this? Because I'm getting it in a form that everybody is familiar with. We're always familiar with the left hand side, the dy over dx plus py is equal to q. So now you can see it was a mission to get to the stage here. You have to know your work. You can't make any silly mistakes with dividing and stuff. Okay. So now let's identify our p and q. So there's our p there. Our p is 1 over x and q is x times sine x. So the next step is our integrating factor, which is equal to e to the integral of p dx, which is equal to e to the integral of, what is my p? You can see most of the time you always get 1 over x there as your integrating, as your p value. So you should get familiar with this here. 1 over x is ln absolute value of x. So now from your log law, e to the power ln, whatever you have is going to equal to this part here, which is just x. Right, so now let's see what's going to happen. So the next step is y times your integrating factor is equal to the integral of q times your integrating factor dx. So y times my integrating factor is x is equal to the integral of q. What was my q? Q was x sine x times the integrating factor, which is x. So now what do we have here? We need to simplify, we need to multiply it So we got x times x there, which is going to be x squared sine x, and then I got y times x on the left hand side. So now, how do we integrate x squared sine x? First of all, the first thing you always do is check, is it possible to let u equal to something? Is this an exact derivative example? If this was x to the power 3, then we could do it. But the fact is, this is x, the derivative of x is not x squared, it will not cancel. So this is integration by parts, very common in N6, integration by parts. Right, so integration by parts. So what is the formula for integration by parts? Right, so we know the formula is when you have the integral of f of x times g prime x dx. This is the question, and then this is the solution, f of x times g of x minus the integral of g of x times f prime x dx. Now, what's the most important thing is to identify f of x. So what is f of x? Is it going to be x squared or is it going to be sine? So you must know this from your priority list. I'm not going to use the formula here. I'm going to use the formula in a different way. I'm going to use the table method because my f of x is not going to be sine x. What's it going to be? It has to be x squared here. Why? Because number 1 is inverse, number 2 is logs, number 3 is powers of x, number 4 is exponential, number 5 is sine. So 3 is above number 5. So therefore, f of x must be x squared. So therefore, g prime x is equal to sine x. Now, we can use the table method. Okay, so how do you do that? You're going to differentiate down to 0. Okay, you will leave on your page there. This is in one line. You will leave a line and then write down the answer. Leave a line, write down the next answer. Instead, I don't have lines on the board, but in your book, you make sure you leave a line for the next one. So you leave a line. Derivative of x squared is 2x. Leave a line here. Derivative of 2x is 2. Leave a line. Derivative of 2 is 0. Right, this can be done very fast. Now, in line with this will be, this is all your integration on this side, this is all differentiation on this side. So when you integrate sine, it's going to be minus cos x. When you integrate minus cos x, it will just be basically integrating cos, which is sine, the negative was already there. When you integrate minus sine, integrate sine, it's going to be minus cos times the minus will be cos x. Right, so now what do we do? The signs, okay, most people are confused with the signs. So how does the signs work? So you will always start, the formula starts, although we do not write down a sign here, it is a positive sign. So that is why you always start with a positive. Then the next one is negative. How many times are you using the formula? Twice, because it's the power 2. If it's the power 3, we will use the formula 3 times. So there's it, positive, negative. The formula is done for the first time. Now for the second time will be your positive and your negative, but let's see here. So it goes positive, negative, and then the next thing is positive. If you want to, you can write a negative, but it's not going to be used. So what do? You multiply now. This way, going down there. That's why I said leave a line here. So it must be done properly. So what do we do now? We multiply f times g. There's f times g all the time. So let's do it here. So I got my y times x is equal to, so I'm going to multiply these two, it's going to give me minus x squared cos x. Now clear with that? Multiplying there, multiplying these two, that's going to be a positive 2x sin x, because a negative times a negative is positive. Then multiply these two here, it's going to be plus 2 cos x plus c, and you're done. That is the table method. We're not given any values to substitute, that is your 5 marks. General solution. Alright, that is a general solution for 5 marks. That is a table method.